Hello everybody, welcome into another lesson. So today we are going to talk about synthetic division of polynomials as well as the factor theorem and the remainder theorem. So synthetic division, unlike polynomial long division, only works with when you're dividing a polynomial by a linear term. Now in polynomial long division, we could divide it by quadratic terms and what have you, but in synthetic division, it only works with linear. So you'll have some polynomial function f of x divided by a linear term of x minus k, that arbitrary x minus k. So the factor theorem states that when you do your synthetic division, if you get a remainder of 0, then x minus k is a factor of f of x. That's all that states. If you have no remainder, then what you're dividing it by is a factor, which we encountered that a bit yesterday in polynomial long division. Then there's something called the remainder theorem. This might actually sound familiar because earlier in the unit we did synthetic substitution, which is basically the same thing as what we're doing today. That f of k is equal to your remainder. So you have some x minus k. Well, you set x minus k equal to 0, x would equal k. So you take your synthetic division, divide by k. That value for f of k equals your remainder. We did that when we did synthetic substitution. I even put that, also known as synthetic substitution. So by the remainder theorem, that's how synthetic substitution works. Which you can extend this to applying it if the remainder is 0, that means your f of k would equal 0 also. So let's get into some examples here. Let's say I have x to the third minus 7x minus 6, that quantity divided by x minus 2. So I'm going to take x to the third minus 7x minus 6, divide that quantity by x minus 2. Alright, well, this time we're doing synthetic division. So for synthetic division, you draw yourself a little table like that. Then for your dividend, so what you're dividing itself, you'll take the coefficients of the polynomial itself, so that x to the third has a coefficient of 1. You don't have an x squared term, so that coefficient will be 0. You have an x to the first term, that coefficient is negative 7. Then your constant term is negative 6. Now, what you're going to divide by, that x minus 2, well, you just set x equal to 2, right? X minus 2 equals 0, you would just get 2. So you're going to divide by 2. Now, what we do for synthetic division, bring down that very first value here in your dividend, that 1. That goes by default. Then you'll take that 2 times 1, which is 2, and you'll put that right below the 0 here. Now what you do next, add 0 and 2, what do you get? You get 2. Once you've done that, take 2 times 2, you get 4. So put that 4 below the negative 7. Negative 7 plus 4 is going to be negative 3. Now what's 2 times negative 3? That's negative 6. So add your negative 6 and negative 6, you get negative 12. Alright, so you have a remainder of negative 12. That very last number to the right of your result is your remainder. That's negative 12, your remainder. So this tells you a couple of things. This will tell you that by the factor theorem that f of 2 is equal to negative 12. That's by the remainder theorem, rather. By the remainder theorem, f of 2 equals negative 12. Then, we also want to write the result out. So, the original polynomial is x to the third. The very first term in your results is one less power than what your original was. So the answer could be written as x to the second plus 2x minus 3, then minus that 12 all over that x minus 2. That's how you would write that. So it almost works similar to polynomial long division. Your remainder works the same way. So what you get down here is going to be one less power than what you started with. The coefficients for one less power than you started with. And since you have a remainder, anything other than 0, x minus 2 is not a factor of x to the third minus 7x minus 6. Okay. Let's do a little bit more here. Now, I'm going to take x to the third minus 5x squared minus 2x plus 24, and I'm going to divide that by the quantity of x plus 2. So I'm going to take the x to the third minus 5x squared minus 2x plus 24, that whole polynomial, and divide it by x plus 2. So let's set up our synthetic division. So again, set up your nice little table here. Now on the right, in the top right, take your coefficients of the polynomial. So that's going to be 1, negative 5, negative 2, and then 24 for your constant value. Now to the top left here, you set x plus 2 equal to 0, you'll get negative 2. So you're actually going to divide by negative 2. What you're going to do next is bring down that first number, that 1, from above. Alright, so what's negative 2 times 1? That's negative 2. So negative 5 plus negative 2 is negative 7. And then negative 2 times negative 7 is positive 14. Negative 2 plus 14, that's negative 12. I'm sorry, that's positive 12. Excuse me, I don't know what I'm thinking. The negative 2 times 12 is negative 24. Well, what do you know? 24 minus 24 is 0. What do you got? You have a remainder of 0. Look at that. You got a remainder of 0. So this means that x plus 2 is a factor of x to the third minus 5x squared minus 2x plus 24. Since you have a remainder of 0, x plus 2 would be a factor of this polynomial, which also means that f of negative 2 equals 0. So now to write the result, that's the 1 is the coefficient of 1 less power than x to the third, what you started with. So the other factor you would get is x to the second minus 7x plus 12. That would be your answer. These are the coefficients of the other factor that you get when you divide by x plus 2. So you get x squared minus 7x plus 12. And if you wanted to, you could factor it even further. You would get x minus 3 times the quantity of x minus 4, but we're not doing that today. That is going to come into play in a future lesson, however. But let's go on here. We have x to the third minus 14x plus 8. That polynomial is going to be divided by x plus 4. Alright, so let's take x to the third minus 14x plus 8, divide all that by x plus 4. Well, let's set up our tables again here. Set up our table. So take your polynomial over here. The coefficient on x to the third is 1. You have no x squared term, so that coefficient will be 0. And then your x to the first term, that coefficient is negative 14. Then your constant is positive 8. And then you have the x plus 4, which you're dividing it by, so you would divide by negative 4. All right. So now the first thing we do, bring down that positive 1. Take negative 4 times 1, you would end up getting negative 4. And then 0 plus negative 4 is going to be negative 4. All right, negative 4 times negative 4 is 16. Negative 14 plus 16 is positive 2. And then, let's see, negative 4 times 2 is negative 8. Well, 8 minus 8 is 0. What do you know? We have actually another remainder of 0. Since the remainder is 0, that means x plus 4 is a factor of this polynomial. So the answer can be written then from down here as x squared minus 4x plus 2. That's exactly what you would get for your answer. X squared minus 4x plus 2. All right, how about this one? 10x to the fourth plus 5x to the third plus 4x squared minus 9, all that is divided by x plus 1. So 10x to the fourth plus 5x to the third plus 4x squared minus 9, that whole polynomial divided by x plus 1. So let's set up our table again here. All right, so 10's our first coefficient. That's the coefficient on x to the fourth. 5 is the coefficient on x to the third. 4 is the coefficient on x squared. We have no x to the first term, so that coefficient will be 0. And then the constant term is negative 9. All right, then we're going to divide that by, set x plus 1 equal to 0, you would divide by negative 1. All right, so now we have it all set up. Bring down that 10 from above. Now what's negative 1 times 10? That's negative 10. 5 minus 10, that's negative 5. Negative 1 times negative 5 is positive 5. All right, 4 plus 5 is 9. Now, negative 1 times 9 is going to be negative 9. 0 minus 9 is negative 9. And then you have negative 1 times negative 9 would actually give you positive 9. Negative 9 plus 9 is 0. So we have yet another remainder of 0. Which means that x plus 1 is a factor of this polynomial since the remainder is 0. So what you get when you divide by that x plus 1, you'll get an answer of 10x to the third minus 5x squared plus 9x minus 9. That would be the answer you should get. After doing the synthetic division, you'll get 10x to the third minus 5x squared plus 9x minus 9. All right. How about this one? X to the fourth minus 6x to the third minus 40x plus 33. All that is going to be divided by x minus 7. So we have x to the fourth minus 6x to the third minus 40x plus 33. That polynomial divided by x minus 7. So let's go ahead, set up our table again here. Alright, so the coefficient on x to the fourth is 1. Coefficient on x to the third is negative 6. We don't have an x squared term, so that coefficient is 0. Negative 40 for your x to the first term, and then positive 33 for your constant term. Now, what are you going to divide this by? Okay, so set that x minus 7 equal to 0, you get an x value of 7. So you're going to divide all this by 7. Okay, so bring down that 1 from above here. Now, what is 7 times 1? That's 7. Negative 6 plus 7 is going to be positive 1. 7 times 1 is 7. Alright, so 0 plus 7, well, that's 7. 7 times 7 is 49. Alright, so negative 40 plus 49, that's positive 9. And then you have 7 times 9, which is 63. So 33 plus 63 is 96. Well, you have a remainder this time. And that remainder is 96. So that means that x minus 7 is not a factor of this polynomial since you have a remainder. So we can say that f of 7 is equal to 96. Now, the answer is going to be, of course, 1 less power than the polynomial you'd start with. So this would be x to the third plus x to the second plus 7x plus 9 plus that 96 over your factor that you were dividing it by of x minus 7. I shouldn't really call it a factor because it's not, but what you should get then is x to the third plus x squared plus 7x plus 9 plus that 96 over x minus 7. That would end up being your answer. I have about 2 more, then we'll be done for the day. All right, let's see. We have 2x to the fourth minus 6x to the third plus x to the second minus 3x minus 3, that polynomial divided by x minus 3. Alright, so we have the polynomial 2x to the fourth minus 6x to the third plus x squared minus 3x minus 3, all that divided by x minus 3. So let's set this up again here. Alright, so coefficients of the polynomial, you have 2 for the x to the fourth, you have negative 6 for x to the third, you have 1 for the x squared, you have negative 3 for the x to the first, then your constant is negative 3. Alright, so what are you dividing this by? Set x minus 3 equal to 0, you get x equal to 3. So you're going to divide all this by 3. Alright, so bring down that 2 from above. What is 3 times 2? Well, that's going to be 6. Negative 6 plus 6 is 0. 3 times 0 is 0. Alright, 1 plus 0 is 1. 3 times 1 is going to be 3. Negative 3 plus 3 is 0. 3 times 0 is 0. So negative 3 plus 0 is negative 3. So you actually have a remainder of negative 3. You've got a remainder of negative 3, which means that x minus 3 is not a factor of this polynomial. But we can say that f of 3 equals negative 3. We can certainly say that. Then what is your answer? So start with 1 less power than your polynomial. The coefficient then would be, you'd have 2x to the third, you'd have a 0x to the second, so you'll go right to plus x, no constant term, so then you'll just do minus 3 over that x minus 3. So that would be your answer. You would get 2x to the third plus x, then minus 3 over x minus 3 for your answer. I have about one more. Got just one more, then we're done. Alright, 4x to the fourth plus 5x to the third plus 2x squared minus 1, all that divided by x plus 1. Alright, so we have the polynomial of 4x to the fourth plus 5x to the third plus 2x squared minus 1, that whole thing divided by x plus 1. So let's go ahead and set this up here. Alright, so take your coefficients of the polynomial. You have 4 for x to the fourth, 5 for x to the third, you have 2 for x to the second. You don't have an x to the first term, so that coefficient is 0. Then you have negative 1 for your constant. Okay, what are we dividing this by? So set x plus 1 equal to 0, you would get negative 1 for your value. So we're going to divide all this by negative 1. Okay, so bring down that 4 from above. Then you'll take negative 1 times 4. What's that? That's going to be negative 4. All right, so 5 minus 4 is 1. Negative 1 times 1 is negative 1. Okay, 2 minus 1 is going to be 1. Negative 1 times 1 is going to be negative 1. All right, so 0 minus 1 is negative 1. Negative 1 times negative 1 is positive 1. So negative 1 plus 1 is 0. Well, what do you know? What do you know? You have a remainder of 0. Since the remainder is 0, that means x plus 1 is a factor of this polynomial. So the other factor answer you should get would be 4x to the third plus x to the second plus x, then minus 1. That would be the answer you get for the other factor. So you end up getting 4x to the third plus x squared plus x minus 1. So that's it for this lesson. Next lesson actually isn't going to be too bad. We're going to talk about Descartes' rule of signs, which will tell us how many positive and negative real zeros for a polynomial we could potentially have. So I hope everyone has a great day. Take care.